Hello College Algebra. I just want to touch on in the first video some review topics. The first half of 5.1 is mostly a review of things you should have seen before, systems of two equations and two variables. Most people are familiar with a few of the techniques for solving those, so I'm going to go over one example of a problem for each of them. So we're going to look at number 1 on page 1, where it says 3x plus 2y equals 11, and negative x plus y equals 3, and it says solve using substitution. Now substitution is where you solve one of the equations, get one of the variables by itself, and substitute it into the other equation. Usually you want to pick the easiest one to get by itself. In this case, that should be the y from the second equation, so I will add the x to the other side. Now, by adding x to the other side, I can take y equals x plus 3, take the x plus 3, and put it in for y in the first equation. So we have 3x plus 2 times x plus 3 equals 11. That is 3x plus, distribute the 2, 2x plus 6 equals 11. That would be 5x plus 6 equals 11. Subtract the 6 over, 5x equals 5, which leaves x to be 1. Now, I need an answer for x and y, of course, so I need to take that one and plug it in to get y. I already have an equation solved for y, so that's the easiest place to do it. Y equals 1 plus 3, so y is 4. Now, how are you supposed to enter the answers? They're really an ordered pair, so you should answer 1, 4 in parentheses. So that's just a quick explanation of how substitution works. There's also another technique called elimination. So if you go to page 2, and we'll do number 3, which is 3x minus 4y equals 1, and 2x plus 3y equals 12. Now, your goal for elimination is to get the same number of x's or y's and the opposite sign, so that when you add the two equations together, then it cancels the variable out. Now, it's hard to turn a 3 or 2 into a 3 or a 3 into a 4, but I can multiply this equation by 4 and this equation by 3. So 3 times the first equation and 4 times the second equation, then I will have 9x minus 12y equals 33, and the second equation will be 8x plus 12y equals 48. So what does that help us do? It helps us, when I add these two equations together, I can get a number. Okay, actually this is supposed to be 1, right? I was like, what's going on here? So this is actually 3x plus y equals 3. I saw 11, but it was just a 1 in your equation, so don't get confused, I fixed it. When I add these two together, I now have 17x. My y's are going to cancel because negative 12y plus positive 12y is 0. 3 plus 48 is 51. And divide by 17, you get x is 3. Now I've got to plug this back in to any of the equations I have to get the y that goes with it. So I will plug it into probably the 2x plus 3y equals 12, but you can pick any one. So 2 times 3 plus 3y equals 12. So 6 plus 3y equals 12. So 3y equals 6. Which means dividing by 3y equals 2. Again, your answer goes in the same form. This is 3, 2. And this is when you have one solution. Now, if you look at page 3, it talks about two different options: inconsistent solutions and infinite solutions. Now, this happens if you plug in either by substitution or elimination, when you cancel out one variable, it also cancels out the other one at the same time. So let's look at page 3, number 1. 3x minus 2y equals 4, negative 6x plus 4y equals 7. Now, in order to get the variables to line up, I would like to multiply the first equation by 2. because that would give me 6x minus 4y equals 4 to line up with the other one. Now what's the problem here? This is equal to 8, just kidding. What happens when I add these two together? My x's cancel, but also my y's cancel, so I have nothing left on the left side. So you get 0 equals 15. Now in what world is 0 equal to 15? I missed 0 questions, I missed 15 questions. Are those two the same? Probably not. This gives you no solution. So when you have 0 equals a different number, you get no solution. This is what's called an inconsistent system. Now, if you look at number 3, down on page 3, you have 8x minus 2y equals negative 4, and negative 4x plus y equals 2. Again, we'll multiply the second equation by 2 to get the x's to cancel out, or the y's. And we get 8x minus 2y equals negative 4. Negative 8x plus 2y equals positive 4. Now what happens when we add these two together? We get 0 equals 0. That's different than 0 equals 15. Because is 0 equal to 15 ever? No. When is 0 equal to 0? All the time. But that doesn't mean every set of x and y is an answer. It just means that basically these are two lines that are sitting on top of each other, and so there's an infinite number of solutions. But if two lines are sitting on top of each other on an xy plane, does that mean every xy is an answer? This point, for example, is not an answer. It's not on the lines that are the solutions. Which means I can pick any x, right? And there'll be an answer for that x, but there's a y that goes with it. So what happens is this is called infinite solutions, but not every solution. The way we handle this is usually we let one of the variables be free. So we say x can be whatever it wants. But once I pick x, say over here, my y has got to adjust to get onto the line. So I need to solve an equation for y and see what it's equal to. In this case, the second equation is easy to solve for y. I just add the 4x to the other side. So if x is whatever it's wanting to be, y will adjust to x. So it's got to be whatever x is, 4 times that, plus 2. So this is how you would write your answer. Now technically, you could also let y be the free variable. In that case, you let y be free, and I have to solve an equation for x. So to solve one of these equations for x, that's basically saying y will pick what it wants to be, x will adjust. I need to solve this equation for x. So to do that, negative 4x plus y equals 2, I will move the y over. Negative 4x equals negative y plus 2, and divide by negative 4 to all the terms. So x is 1/4 y, because negative divided by negative is positive. Now 2 divided by negative 4 will become negative 1/2. So if y is whatever it wants, x will be 1/4 y minus 1/2. These two represent the same things, it's just a conversion from one to the other. Your homework may ask you to let y be the free variable, in which case it should look like this one. It may ask you to let x be the free variable, in which case it looks like this one. So just be aware of that. Whichever one it asks you to be free, that's the one that gets to be itself, and the other one has to adjust to it. So we'll talk more from 5.1 about systems of equations in 3 variables, but for now this should be a refresher on the 2x2 equations.